The zombie apocalypse. What we're going to be doing is calculating the mass of the zombie, half the zombie can that you see here. And so we don't know the mass of this, and we're going to find it indirectly using momentum and momentum conservation and also projectile motion. So how we're going to do it, we've got our zombie blaster, which is right here. And it's just a spring, so when you pull it back, you can see it loads the spring. And we put our dart in there. Now what I'm going to allow you to do in this task is you will be allowed to figure out the mass of this by just putting it onto a scale and figuring out what the mass of the dart is. From there, once you've loaded it, you're going to simply find a desk or a table, anything you want, and you're going to fire the gun, the dart blaster, the zombie blaster, whatever you want to call it, into this. And what theoretically should happen is it should shoot out, stick like this, and then fall to the ground. The only things you're allowed to measure are the mass of this object, and either the distance of the height or the distance where it lands or the time. If you do a slow motion video, you could find out the time it takes to reach the ground. And the key is that you're going to be using momentum conservation to be able to determine the mass of this object. Afterwards, you'll be able to take this half can zombie, place it onto a scale, and determine the percent error. Now, the one thing you'll have to do before this happens is you need to figure out how fast the dart leaves the gun, right? This makes sense. So to do that, you're gonna have to come up with a way to calibrate it. You could do things like fire it horizontally off the table and see where it lands and do some calculations. You could fire it straight into the air, not here, because you'll hit the roof, and from there determine what the muzzle velocity is as it leaves. You're gonna need to do it a few times to find out what the average muzzle velocity is, because for this type of inelastic collision, you do need to know what this initial speed is in order to find the mass. At the end, you're going to be calculating the percent error, how close your calculation came to the original. Now I can try this out and see if it works. Oh, it's hard to get it to stick. A little practice. It'll take you some time maybe to do it. Oh, that was pretty close. Anyways, you get the idea, but you can only do the measurement where it sticks into it properly and falls together, right? Otherwise, it's not an inelastic collision, and it becomes a partially inelastic collision, and we can't do the calculations for it for this type of activity. That's all. Good luck.
Beginning of it?